What is real part of xt? It is xt plus x star t. So what are the Fourier series coefficients? If Fourier series coefficients of xt are ak, then what about Fourier series coefficients of x star t? It's complex.
A star minus K.
It is a star minus k. So real part of xt means it is sum of these two. Okay. Sorry, it is not. Divided by 2 is also there, isn't it? Because okay. Now what about this x3t? Okay, this is interesting. I will explain this. X3t minus 1. How many properties you have to use? There is a scaling and there is a shifting. We have to use two properties. Okay. So let us start with, if xt is, let us start with xt. Let's say Fourier series coefficients of that xt with respect to period t is ak. Now what about, then you are, first let's say t to t minus 1, that is delay by 1. So you will get a signal xt minus 1. What are the Fourier series coefficients of this xt minus 1? What is the time shifting property?
ak times e to the power minus.
It is ak e to the power minus jk omega naught into t naught. T naught is 1 here. So it is minus jk omega naught, isn't it? Okay. With respect to which period?
T naught.
It is with respect to, I think it is given as t. Let's say t, capital T. Now if you are doing t to 3t, that is scaling by a factor of 3, compression, you will get x3t minus 1. Now tell me, what is the fundamental period of this signal?
T by 3.
Sorry?
T by 3.
Okay, so we can find a Fourier series representation with respect to t by 3. What is that? What is the property of time compression?
Same as xt minus 1.
Sorry? It is same as this one. The property is that if xt with a Fourier series with respect to some period t naught, if they are ak, then xt, I think it is x alpha t, that is with Fourier series with respect to t naught by alpha is the period, and it is ak. Is it? And here we assume that ak is positive. In that case, these are the Fourier series coefficients. With respect to that period t naught by alpha, you will get the same. I have proved this in the class. Okay. So what is the answer? Is it ak into e to the power minus jk omega naught? Is it?
So we will have to convert it to period T, I guess.
No, I have not asked it specifically. Did I ask specifically to convert it into E? I have asked to find the. I have asked you to find the Fourier series coefficient, Fourier series
Okay,
representation. Okay. If it is asked if you are asked to find the Fourier series with respect to t, then what do you have to do?
So then BK becomes AK by 3 for
AK by 3. Everywhere you
multiples of
AK
3.
by 3. Okay, you have to insert zeros in between, isn't it?
Yes, sir.
So you can write any of these answers, but you have to specify. Only thing is that you have to specify the period with respect to which you are taking the Fourier series representation. Okay.
Okay, sir.
Fifth question is, you are given a signal xt sine 10t. I think part of this question was asked in the quiz, isn't it? To find the period. Is it? Was it the same question?
Yes, sir.
Yes. Okay. You can use different property. The solution is not unique. Approach is not unique. So you can use different approaches to solve this question. I will explain you two methods. One is using the multiplication property. What is the multiplication property? Can we consider this as a sum of the product of two periodic signals? Is this a
Yes, sir.
periodic signal sine 10t? What is the
Yes,
period
sir.
of that? Sine
Pi by
10t.
5.
Pi by 5. It is a periodic signal with period pi by 5. And what about this?
2 pi.
It is 2 pi. I have already sent you the solution. This is a periodic signal with the period 2 pi. Now, if let us assume that you are asked to find this Fourier series representation of this xt using multiplication property. Can we apply the multiplication property directly? What is multiplication property? If x1t Fourier series ak x2t bk, then x1t into x2t, what are the Fourier series coefficients?
AK convolution BK.
AK convolution.
AK convolution bk. And you have to be careful that you have to find this Fourier series representation with respect to same period. Then only it makes sense. This convolution. Okay. Now, what is the, so if you want to apply the multiplication property with respect to which period we have to take the Fourier series representation?
2
2
pi.
pi.
It is 2 pi because you have to consider the LCM of these two. That is the period of the resulting signal. Now, what are the, first let us consider this sigma k minus 3 to 3 1 upon 1 plus jk e to the power jkt. This is a periodic signal with fundamental period 2 pi. What are the Fourier series coefficients of this with respect to 2 pi? What are those? Is it directly given in the Fourier series summation form? Suppose the Fourier
Yes,
series
sir.
coefficients of this signal are ak. What does it mean? This signal can be written as k minus infinity to infinity ak e to the power j. What is the fundamental period? Fundamental frequency jk omega naught t. Omega naught is what? If t
1.
it is 1, so it is kt. You compare these two, you will get the Fourier series coefficients directly, isn't it? What are the Fourier? How many non-zero Fourier series coefficients?
6.
There are 7 non-zero Fourier series coefficients, isn't it? There are 7 non-zero Fourier series coefficients. So can we write this as, I am writing it as, let's say, AK. AK is what? 1 upon 1 plus jk in for which values of k?
Minus 3 to 3.
K from minus 3 to 3 and 0 otherwise. Is it?
Yes, sir.
Yes, sir.
Now what about this sine 10t? What is the Fourier series with respect to its fundamental period? T naught is pi by 5. Is it this? Any sinusoidal signal, any sine wave, Fourier series representation with respect to its fundamental period will be this. Is it?
Yes, sir.
Yes, sir.
Now,
Yes,
what is the for applying the multiplication property, we have to find the Fourier series representation of this signal with respect to period 2 pi, isn't it?
Yes, sir.
Yes, sir.
So sine 10t Fourier series t naught 2 pi. What are those? This will be 0. How many zeros you have to insert?
7.
10.
9 zeros. If you are, oh sorry, you are taking with respect to how many times? 5 times. Sorry, 10 times, isn't
10
it?
times.
10
Yes.
times means 10 minus 1
9.
zeros you have to
Yes.
insert 9 zeros. So where will be the next non-zero value? This is at
10.
10. A or B, whatever you call it, is at this point. This is 10. At that point, it is 1 by 2j. And here, negative side, here also you have to insert 9 zeros. So this will be at minus 10, you will have minus 1 by 2j. Is it? That is
Yes, sir.
sine 10t. Now you have to apply the multiplication property. What is multiplication property? Multiplication property is what?
AK convolution.
It is AK convolution, this one. And let's say these are PK. Okay, this is PK means B10 is 1 by 2j and B minus 10 is minus 1 by 2j. Okay, now what is AK convolution BK? Can we use the property of delta function? What is the property of delta function in convolution? If you convolve any signal with delta function, what will you get?
Same function.
Same function. And if you convolve with a delayed delta function, what will you get?
Delayed
Signal
function.
delayed by that much amount. So can we say that these are two Kronecker delta functions, delayed Kronecker delta function? One is at 10 and other one is minus 10, and its amplitude is minus 1 by 2j and minus 1 by 2j. Is it that?
Yes, sir.
BK.
Yes, sir.
Now you are convolving these two. So we can use the linearity property. This is sum of two impulse, this Kronecker delta function, delayed Kronecker delta functions. So first you convolve this with one of them. Second one, add those two, isn't it? So what is if you convolve with this, what are the Fourier series coefficients? Look, in AK, there are 3 non-zero Fourier series coefficients. Not 7, from minus 3 to 3. Now, what will happen if you convolve with that sequence with this? This will be shifted right by 10. Is it? Because this is delayed by delta function delayed by 10. So this sequence will be shifted right by 10. So can we say that, what is the expression? What is the delay operation? Here, this is a sequence in K. If we are delaying it by 10 means what? You have to replace K with what?
K minus 10.
K minus 10. So is that expression is 1 upon 1 plus j k minus 10. And there is a scaling factor 1 by 2j. And in which interval this is non-zero? You have to replace this k also with k minus 10, isn't it? You have to right shift. In which interval?
7 to 13.
It is 7 to 13. 7 to 13, it is non-zero. Now what happens in this interval? This one? If you convolve this sequence with this shifted impulse?
It will be replaced by K plus 10.
So is it minus 1 by 2j 1 by 1 plus j k plus 10? Because it is shift left, isn't it? Shift left means you have to replace, left by 10 means you have to replace k with k plus 10. And this is in which interval for k? Is it minus 13 to minus 7? So the Fourier series coefficient, let's say Ck of this Fourier signal xt, they are this one in this interval, this one, and 0 otherwise, is it? That is using multiplication property. Okay. Now, can we use any other property to find this Fourier series coefficients? What about this sine 10t? Okay, sine 10t. Sine 10t into 1 upon summation k minus 3 to 3, 1 upon 1 plus j k e to the power j, what is that, j? kt, isn't it? Okay. Now, can we use the frequency shifting property? What is frequency shifting property? If you are given a signal xt, Fourier series with respect to period t naught is ak, then if you multiply that signal with the mth harmonic e to the power j m omega naught t, what will be the Fourier series coefficients of that signal?
AK minus m.
It is ak minus m. So can we use this property here? We can write sine 10t as e to the power j 10t minus e to the power minus j 10t by 2j, isn't it? So this into Okay. So if you use this frequency, this is called the frequency shifting property. If you use the frequency shifting property, there is a shift by 10 and one shift by minus 10, isn't it? Will you get the same answer?
Yes.
You'll
Yes.
get this. You'll get the same answer. Okay. Which one is easier, this one or the convolution one?
This one.
This one.
This one.
This one. Okay. So you can use any of these methods. Okay. And convolution is also not that difficult if you can quickly identify that convolution with delta function and all. Okay. That is also not that difficult. Anyway, it's up to you. You can use any method.